second one, if x square minus 6x plus 5 is equal to 0, x square minus 6x plus 5 is equal to 0, and x square minus 12x plus p is equal to 0 have a common root, find p. Then find p. So again you can see that word common root. So whenever you are listening that word common root, we can do that problem by using this formula. Again, by comparing here the first one with a1x square plus b1x plus c1 is equal to 0, we can have a1 is equal to 1, b1 is equal to minus 6, and c1 is equal to 5, and correspondingly there a2 is equal to 1, b2 is equal to minus 12, c2 is equal to p. By substituting all these values, you can get that problem r. Given equations are so x square minus 6x plus 5 is equal to 0, and x square minus 12x plus p is equal to 0. Equation 1, equation 2, let's call. Now equation 1 is a direct quadratic equation, we can solve that one. X square minus 6x plus 5 is equal to 0. So 5 can give factors, 5 ones are 5. And here you can see minus 6, minus 5, minus 1. Now right here implies x square minus 5x minus x plus 5 is equal to 0. Taking x common, x minus 5 minus 1 common, x minus 5 is equal to 0. So x minus 5 into x minus 1 is equal to 0. Therefore x is equal to 5 or 1. Now these two are having a common root, so that common root may be 5 or that common root may be 1. Since 1 and 2 have common root, then at x is equal to 5 from 2 we use equation 2. So 5 square 25 minus 12 into 5 60 plus p is equal to 0. So 25 minus 60 minus 35, taking the side p is equal to 35. Next, at x is equal to 1 from 2. So again substituting this one, so 1 minus 12 plus p is equal to 0 and p is equal to 11. 1 minus 12, that is equal to minus 11, taking the p is equal to 11. This is one model, and you can use that formula to do that problem also. So x square minus 6x plus 5 is equal to 0 మరియు x square minus 12x plus p is equal to 0 అనే సమీకరణాలు ఉమ్మడి మూలాన్ని కలిగి ఉన్నవి. అయితే p విలువ కనుక్కోండి అని ఇవ్వడం జరిగింది. మళ్ళీ సూత్రాన్ని ఉపయోగించి లెక్కన చేయవచ్చు. ఇచ్చినటువంటి సమీకరణాలని స్టాండర్డ్గా ఉన్న ప్రామాణిక సమీకరణాలతో పోల్చినట్లయితే a1 is equal to 1, b1 is equal to minus 6, c1 is equal to 5. అక్కడ రెండో సమీకరణంలో a2 is equal to 1, b2 is equal to minus 12, c2 is equal to p. అలా ఈ సూత్రాన్ని ఉపయోగించవచ్చు, లేదా ఇక్కడ ఇంకో పద్ధతి చెప్పడం జరిగింది. ఇచ్చినటువంటి సమీకరణాలు x square minus 6x plus 5 is equal to 0, x square minus 12x plus p is equal to 0. ఇది మామూలు వర్గ సమీకరణం, దాన్ని సాధించడం మనకి తెలుసు కాబట్టి x square minus 6x plus 5 is equal to 0, కారణాంకాల పద్ధతిలో 5 1 5 -6 +5 కాబట్టి -5 -1 అని తీసుకుంటాం జరిగింది. ఇక్కడ నుంచి ఎక్స్కి 2 విలువలు వచ్చింది. సో ఈ రెండింటికి ఉమ్మడి మూలం ఉంది కాబట్టి ఆ ఉమ్మడి మూలం 1 అయినా కావచ్చు, 5 అయినా కావచ్చు. కాబట్టి 1 మరియు 2లో ఉమ్మడి మూలాన్ని కలిగి ఉన్నవి కనుక x = 5 సమీకరణం 2లో ప్రతిక్షేపించినప్పుడు 5 స్క్వేర్ 25 -12 × 5 60 ప్లస్ p = 0 25 - 60 -35 కుడి చేతి వైపు తీసుకెళ్ళినట్లయితే 35. x = 1 రెండో విలువను ప్రతిక్షేపించినట్లయితే సమీకరణం 2 నుంచి 1 - 12 ప్లస్ p = 0. సో p = 11.
x square minus 5x plus 6 greater than 0. X square minus 5x plus 6 greater than 0. Under what conditions? These are positive ones. Here, let us apply factorization. Factors for 6 such that their sum or difference must be equal to 5. As the symbol is plus here, the sum must be 5. So we can rewrite this as 2x, 3x plus 6 greater than 0. X into x minus 3 into x minus 2 greater than 0. X minus 2 into x minus 3 greater than 0. X such that x does not belong to closed interval 2, 3. How did you write down this one? I will rewrite the supporting rules here. X minus alpha into x minus beta less than or equal to 0. X belongs to closed interval alpha beta. X minus alpha into x minus beta less than 0. X belongs to open interval alpha beta. X minus alpha into x minus beta greater than or equal to 0. X does not belong to alpha beta. Sorry, open it. X minus alpha into x minus beta greater than 0 implies x does not belong to closed interval alpha. These 4 supporting rules we shall take up. Our present problem comes into the last model. This one, x minus alpha into x minus beta greater than 0. Then x does not belong to closed interval alpha beta. That's what I wrote. In the place of alpha we are having 2 and in the place of beta we are having 3. So x does not belong to 2, 3. What is the meaning of this one? Suppose on graph sheet if you mark out the numbers like this 1, 2, 3, 4, 5, 6. According to this one, x is a number, real number, which will never take value starting from 2 up to 3. In this area, it will never take. In this area, it will never take. So what can it take? If you take up that question, it can take value below 2 and above 6, above 3. That is, x such that x belongs to minus infinity 3 union, minus infinity 2 union 3 infinity. Sir, what is the meaning of this one? X is a number which can take value below 2. Below 2, how many numbers are there? Infinitely many. That's why minus infinity. Or x can take value above 3. After 3, how many digits are there? Infinity. So above 3, infinity. Below 2, minus. So x can take values here. X should not take value. If you want to write down in this notation, you have to write down x does not belong to closed interval 2, 3. Sir, does not belong notation we don't want. Then x belongs to open interval minus infinity to union 3 infinity. In these two notations we can take this, particularly these 4 conditions we can derive from theorem of real rule. We shall come to know the proof of that one in our next coming classes. So, theorem of real. For that, if you remember these four different conditions, any quadratic inequality, we can solve. On our present problem, under what conditions the following inequalities are positive, he specified. Positivity means greater than 0. That's why I have put greater than. Sometimes he may ask under what conditions the following inequalities are negative. If it is negative, less than 0, we can. Okay, sir. Next.